Hello everyone, we're going to work on section 9.4, which is about the chain rule. So using the chain rule, we're going to find the derivative of z with respect to t. As we talked before, it's a good idea if you write a diagram here for yourself. It's not an obligation, but it helps you. So based on the information that we have here, we know that z is a function of x and y, x is a function of t, and y is also a function of t. So using this little diagram, we will conclude that the derivative of z with respect to t will be the derivative of z with respect to x times partial derivative with respect to t, or it's better if we write it as d, plus partial derivative with respect to y times derivative of y with respect to t. So partial derivative of z with respect to x will be negative sine of whatever we have, x plus 4y, times derivative of x with respect to t is 5 multiplied by 4, which is 20t to the power 1 less, plus the partial derivative of z with respect to y will be negative 4 sine of x plus 4y times the derivative of y with respect to t is negative 1 over t squared. We can simplify this later, but it's for these kind of questions, you don't need to simplify unless it is mentioned in the question, or it's obviously in a way that you know you're going to simplify that. Part B follows the same pattern here. Z is a function of y and x. Each of them is a function of t. And we're going to follow the same formula here. You should write it here, but I should not write it here. So for this, partial derivative of z with respect x and y will be different. So dz dt is going to be partial derivative of z, which is tan inverse of y over x. We know that y over x can be written as y times 1 over x. So when taking derivative with respect to x, we're going to do that here, which is negative 1 over x squared, and we're going to multiply it by the y, which is next to it. So it will be negative y over x squared as the derivative of inside. But what is the derivative of tan inverse? That would be 1 over 1 plus x squared if we only had x inside. But in here we have y over x to the power 2. So this is partial derivative of z with respect to x times derivative of x with respect to t is e to t itself plus partial derivative of z with respect to y. So this time we're going to find the derivative of y here, which is 1 times 1 over x. So we would have 1 over x as the derivative of inside, and 1 plus 1 plus x y over x squared as the derivative of tan inverse of y over x with respect to y. And derivative of y with respect to t will be e to negative t. Question number 2. Z here is again a derivative, a function of x and y. X is a derivative x is a function of s and t. Also, y is a function of s and t. So in order to find the partial derivative here, it's going to be z over with respect to x times x with respect to s plus partial derivative with respect to y times dy ds. And it will be, for the first part, partial derivative of z with respect to x. The derivative of e to x is itself times sine of y. Dx ds will be just t squared plus partial derivative of z with respect to y. We keep e to x here, and the derivative of sine of y is cosine of y, times derivative of y with respect to s, that would be 2st. Next part is partial derivative of z with respect to t. So we only change these parts. And of course, the first part remains the same, but this part changes, because it will be the partial derivative with respect to t, here dx dt, because we're going to follow this. And also here t. So first parts are the same as before. The derivative of x with respect to t will be 2t, and derivative of y with respect to t will be s squared. Number 3, a function as z equals f of x and y is given to us. We know that f is differentiable, and we know that x is a function of t. Y is a function of t, but another function, not the same function. G of 3 is 2, h of 3 is 7, g prime of 3 is 5, and h prime of 3 is -4. Also, we know that partial derivative of function with respect to x is 2 at 2 and 7 is 6. Partial derivative of f with respect to y at a point 2 and 7 is -8. So dz dt will be partial derivative of f with respect to x times derivative of x with respect to t. Because f is a function of x and y, each of them is a function of t. So partial derivative of f with respect to y times dy dt. We're going to find this at the given points. So the first part will be partial derivative at the point 2 and 7 times dx dt. So x is g of t, dx dt means g prime at the point, plus partial derivative of f with respect to y times dy dt. Since y is a function of t, this will be h prime at that point. So plugging the numbers that we have, the first one is 6 times 5, -8 times -4. And the answer will be 62 here. Next page, number 4. We have sine of x plus cosine of x equals sine of x times cosine of x, and the question is asking for dy dx. So obviously this is implicitly, and we're going to move them to one side. So let's say capital F of x and y. We move everything to the left. So we would have sine of x plus cosine of y minus sine of x cosine of y equals 0. Following the formulas of implicit functions, in here we're going to write that as negative capital F with respect to x. The derivative of capital F with respect to x over the derivative of f with respect to y. In order to remember these, we told that since this is x, this one will be x, and these two will be y, will be the same. Following this, we're going to write as negative. Finding the derivative of capital F with respect to x gives us cosine of x minus cosine of x times cosine of y over partial derivative of capital F with respect to y gives us negative sine of x minus sine of x times sine of y. So we can factor out cosine here. That would be 1 minus cosine of y over sine of y, and this will be 1. Okay, when you factor out sine of x here, you would have negative 1 minus sine of y. And also we have a negative here because we had that here. So we can apply the negative to the bottom or maybe the top if you like. So we would have cosine of x times 1 minus cosine of y over sine of x times 1 plus sine of y. Last one is something like the previous one. So we can write this as capital F, but this time instead of 2 variables, we will have 3 variables. And that would be y times z or z times y minus ln of x plus z equals 0. In order to find partial derivative of z with respect to x, we're going to use the partial derivative of capital F with respect to x over partial derivative of f with respect to z. And that would be when you find partial derivative of capital F with respect to x, the first term doesn't have x, so the second term will have negative 1 over x plus z, and partial derivative with respect to z, both terms have z, so y minus 1 over x plus z here. We can simplify this as 1 over y times x plus z minus 1. Also, let me write that here. When you want to find the partial derivative of z with respect to y, that would be negative partial derivative of capital F with respect to y over partial derivative of capital F with respect to z. And that would be negative z over y minus 1 over x plus z. And this can be simplified as z times x plus z over y times x plus z minus 1. You can use the common denominator and then multiply them together.